Hi, welcome to another video about trig. We are starting sine and cosine, and we're starting to graph those things. Miss White already posted a video about sine and cosine and how to graph those, how to use parent points to graph those, and then she presented a lot of vocabulary that you definitely want to know before you start this video, because I'm going to use that. And this video is about taking a graph and writing an equation from that. So we're only dealing with vertical stretch and shrink, so that's going to be important to keep in mind when we look at this page here. But given that we know, well, what we learned from Miss White with sine and cosine, we know the parent points of sine and cosine, we know the period of sine and cosine, and we can track down other these features in other graphs. So first of all, I'd like you to decide which one of these graphs is sine and which one is cosine. So if you'd like to pause, take a little bit, and see which one you think is sine or cosine, then you can come back and I'll reveal that. So first thing I notice when I'm deciding on if something is parent sine or parent cosine is I look at where is my axis. So you can see my y-axis right here on each, and then my x-axis is right here on each. So I like to look at the peak being on that y-axis, or the 0 being on the y-axis. That's how I tell the difference between what I'm going to use sine or cosine. When we talk about like horizontal movement, which we're not dealing with today, then this becomes a little bit irrelevant. We can actually make a sine function look like a cosine function because they share the same pattern, just shifted some. But we'll explain more of that in the future. So for now, I know that this left function is parent cosine because it starts at a peak. So this is cosine of x. And so this must be parent sine because it starts in the middle of its period. Or what we'll learn later as the middle line. That's the middle line of, I guess, the amplitude. That splits the amplitude, I should say. So after you've done this, after you've figured out which one is sine and which one is cosine, we're just going to put little points to show the first period of each function, just because these are going to serve as guidelines to how we find patterns in our graphs. So cosine starts at a peak, goes to a 0, then a valley, 0, another peak. That's the first period, first full period of cosine. And sine, as we talked about, starts in the middle of its period at a 0, and then goes to a peak, goes to another 0, goes to a valley, and then finishes off at another 0 for its first period. So I put these, I just kind of shifted them to show you that they do look pretty similar. And so you need to really make sure that you're looking at the right spot on the graph, especially when we know this isn't these graphs aren't shifted at all. If you remember unit circle, you can also use that to help you remember which one is which. Cosine is 1 when the angle is 0. Cosine is 0 when the angle is pi over 2. Sine is 0 when the angle is 0 pi or 2 pi. That would help you determine these as well. So Miss White went over these transformations with you. Remember, you can move some of these transformations around. Because addition is commutative, you can add d to the end, which is traditionally how we see it. Like it could not look like that and just have a plus d on the end. for that vertical shift. So if you remember, D is the vertical shift in every case here, A is the amplitude, or how much these graphs are stretched vertically. So for these following graphs, so 1 through 8 here, the vertical shift and stretch will be modified from the parent sine cosine functions. Determine the equation of each graph. So we're going to decide first if it's sine or cosine by a similar method that we talked about before in this first little intro. And then we're going to locate something called the middle line. This is going to split the amplitude into, I guess it splits the amplitudes, because the amplitude is measured by the distance from the middle line to the peak or to the valley. So this is going to tell you if there's a vertical shift, depending on where the middle line is. If that, and you can see it's the middle line because it's going to almost split it in half vertically. It'll split the function in half vertically. So the amplitude, again, is centered around the middle line. So we're going to locate that when we determine these equations. So if we take these two examples, for number 1, I'm going to notice my middle line just by looking at the symmetry, making sure that I have an equal amount of amplitude above that line and an equal amount of amplitude below that line. And I'm going to notice that the units from my middle line to a peak or to a valley is 2. So that's my A value. So my A value is 2. That's my amplitude. Oh my gosh, I'm getting out of order. I'm so excited about the middle line. So I've started on those 2 bullet points, but the first thing we forgot to do is decide if this was cosine or sine. If we go back and we look at the axes, I see I have a y-intercept at a peak in my pattern, in my trig function. So which function, sine or cosine, starts at a peak? That would be cosine. So cosine of x is going to be the function we'll use here. So cosine of x. And then, like I was saying, our amplitude is 2, so that's what we're putting right here. And then for the shift up or down, this middle line is normally, if we remember the parent function, the middle line is normally at y equals 0. It's normally just on the x-axis. So instead, this middle line has been shifted down, which we can see right here. It's been shifted down 1. So I'm going to put -1 to represent where all my values got shifted to. So this is going to be really important for you to know where that middle line is, because it's going to basically serve as your sort of landmark to get the equation in here. So that's the equation of number 1. Number 2 has a really thin function. And since these functions aren't shifted left or right, I know that where I'm looking on the y-axis is going to help me decide if this is sine or cosine. Now, you could probably figure, since this is an example, this one's going to be sine. But another thing that gives that away is I'm not hitting the y-axis, right? This is the y-axis, on a peak or a valley. I'm hitting it in the middle of that, where maybe if this were the parent, this used to be where 0 was. So since I'm not hitting at a peak or valley, I know this is sine. So this function is sine of x. And I do see that normally, maybe I could draw sine on this graph as well. Normally sine would go through 0 and then pi over 2, and then at pi, we'd be back at 0. Oh, that should say 3 pi over 2. And at 3 pi over 2, we go back down to -1. So normally sine looks like this. If we're going to put it on our graph, the parent sine does. So clearly, this graph has been shifted. Its middle line has been shifted up to 2.5. So plus 2.5 is what I'm putting there, or 5/2 if you wanted to use a fraction. And the amplitude is going to be the distance from the middle line to the peak or to the valley. So if we are just careful, we can see that that distance is just 1/2 of a unit. So I'm going to put a 1/2 here. And because I can't stand mixing fractions and decimals, I'm going to change that to 5/2 on the end. There we go. So this is our equation for the second one. I'd like you to try the rest of these. So 3, 4, 5, 6, 7, and 8. And I'll come back on and show you the answers. Oh my gosh, first of all, I hope you caught this. I didn't put a negative in front of that 1/2. You might have noticed that this graph started going down. Oh my gosh, it started going down before it went up, like normal parent sine does. So you're going to want to make sure your answers down here account for that. So maybe pause again and make sure that you've accounted for those negatives, if there are those negatives in those problems. All right, we got it sorted out. So here's 3 and 4. Both of them are sine. The trick was finding those middle lines, right? I hope you found them. There's our middle line. There's our middle line. On 5 and 6, they're both cosine. They have middle lines, and I did provide some hints there in case you were kind of lost in the grid. There's our middle lines for those functions. Both represented negative cosine. Number 6 was a little tricky too. You kind of had to piece it back together and know that the period, this is 2 pi right here, the period starts over after it goes a full period. And for cosine, that period ended with 2 pi. So then this is like a fresh period starting over again with these new points. Maybe if you want to draw the rest of it out and kind of backtrace towards the y-intercept, that might help you because the y-intercept isn't on that one. Number 7 has a middle line that's on a 1/2 of a unit. Same with number 8. And number 7 also was not on the y-axis, so you had to really remember the pattern of cosine and where the period starts and ends. So this point right here is actually I guess, where the first negative period ends if we go from right to left. If we could sort of sketch kind of a ghost graph of the rest of it, this graph would go up here and it would pretend that this graph for number 8 is not there, but this would be where the y axis is, this peak right here. So again, if you're super stuck on numbers 6 and 7, then maybe just maybe take this to Desmos and see how I found these graphs and see how I got these little viewfinders for them. So my video is about over. Thanks for doing it with me. The practice you'll have in class, if you remember the Desmos polygraph, we're going to have something like that, so we can play some little matching together and just sort of use the words that Miss White presented to us and make sure we've got these first couple transformations mastered. Thanks for watching, and I'll see you guys later. Bye.